So we're working more with our parallel and perpendicular lines. And now the question is, how do we know lines are perpendicular and how do we know they're parallel? A lot of this is review, but we're looking at it a slightly different perspective of how do we deductively show the lines are perpendicular and deductively show they're parallel. I got my little pictures up here. It's just cute. Okay. So we're going to have to do another postulate and three theorems, and these are converses of the ones we did last time. We had a postulate, well, these are them, right? These are the ones we did last time. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Alternate interior angles of parallel lines are congruent. Alternate exterior angles of parallel lines are congruent. And consecutive interior angles of parallel lines are supplementary. Now, the way I just said that, if I was using any of these in a proof, that's what I would be writing. Chances of me remembering these particular words are small to none, but I can remember that corresponding angles of parallel lines are congruent. And then I don't have to remember who's the postulate and who's the theorem. Now, all the converses of these are true as well. So now we have to see if we remember what a converse is. So if P implies Q, what's the converse statement, Joseph? Q implies P, remember that? So if it's an AJ, we have math, and if we have math, it's an AJ, right? We just kind of turn them around. So the converses of those postulates and theorems that we looked at last time are all true. These are biconditional statements, right? Isn't that what that means? Your converse is true, you have a biconditional statement. So here they are. The corresponding angles, converse postulate. Alternate interior angles, converse theorem. Alternate exterior angles, converse. So if you love memorizing these little names, you're like, I'm not going to remember what they actually say, I'm just going to remember their little names. Now you've got to remember which one is the front direction and which one is the converse. So we're going to have to try to remember those things, and I personally think that's hard. Basically all they say, this postulate says, if you have two lines that are cut by a transversal, and if those corresponding angles are congruent, then it must be that the lines are parallel. So remember, our original one said if the lines are parallel, the corresponding angles are congruent. This one says if your corresponding angles are congruent, then the lines are parallel. So we're opposite now, we're converse. Yes? Well, you have to tell us that. Remember, not all converses are true. So this one's a postulate. They're basically telling us it's true, but the theorems are proving that it's true. And again, in the interest of time, I do want to get through a lot today. I may just show you one of these proofs. The other ones are similar, plus I think you are capable of reading through them now. Remember, these notes are all on my calendar if you want to kind of look at the proofs in a little more detail. For example, the alternate interior angle converse theorem, basically we're saying I've got two lines. See, there's no markers here that they're parallel. I don't know that yet. What I do know is that their alternate interior angles are congruent. So I want to conclude that the lines are parallel. That's my conclusion. So if I'm given these are congruent, I can say 1 and 4 are congruent since vertical angles are congruent, which means 1 and 5 are also congruent by the transitive property of congruence, because 4 and 5 are congruent, 1 and 4 are congruent, right? These match, therefore these are congruent as well. Excuse me? And just one more, can I finish my thought, please? If 1 and 5 are congruent by the postulate that says if your corresponding angles are congruent, then the lines are parallel, that's where I'm getting there. Basically, the other proofs are very similar, so I am going to leave that with you. This is something that you really like looking at these proofs. Please do so. They are on the calendar for you to just kind of chug through and follow them all the way through. So if you have supplementary consecutive interior angles, you will have parallel lines. And if you have alternate exterior angles that are congruent, then it must be that the lines are parallel, working backwards. So let's look at an example here. So find the value of x. That makes m parallel to n. So I'm not given that they're parallel. This is slightly different than what I asked you last time. Last time I said they are parallel, find x. I can invoke a theorem that says if you have parallel lines, then they are congruent. Now, if I don't know they are parallel yet, well, when would they be? They would be if those measures are equal. So if you set them equal and find the x that makes it equal, then you will have parallel lines. And Amy, did you have a question? She was just going to do it. Now what's your answer? 20, right? So it's the same process. It's a slightly different thought process. Okay, if x is 20, then the lines will be parallel. That's what this is saying. What else we got here? And then this one says, can I prove these lines are parallel? Are n and n parallel lines? Now, what would have to be true for them to be parallel lines, Jack?
The two angles are supplements to each other.
Right, because these are our consecutive exteriors. Are they supplementary? Does 105 plus 75, does that equal 180? Well, let me, oh, look at that. It does. So that means since the consecutive exterior angles are supplementary, then the lines are parallel. Yes, we can conclude that. Yeah?
Consecutive
Great, nice
They
stuff,
are,
Coach.
figure that out. So anyway, we're doing that to show that the lines are parallel. Okay, here we go. So here's a new theorem. And again, these are not real complicated theorems. This one says that if two lines parallel to the same line, if two lines are parallel to the same line, then they're parallel to each other. It's kind of a transitivity of parallel, isn't it? So the transitive theorem of parallel lines. So if P and Q, if these are parallel lines, and Q and R are parallel lines, well look, I mean, we can see that, right? So, I mean, it's a fairly obvious one. So they're going to jump around with a bunch of different angles here. Use a little transitivity to show that we've got some alternate interior angles that are congruent to prove that these lines are parallel. But we can use parallel as being transitive. So if this is parallel, P parallel to Q, Q parallel to R, P is going to be parallel to R as well. So we've got transitivity. So in the example right here, we're on the bottom of page 1, each rung of the ladder is parallel to the rung directly beneath. So I'm marking up my diagram. I still have people who are refusing to mark up a diagram. You got to. That's how you can see what's going on. So now they want to say, well, why is the top rung parallel to the bottom rung? Can anybody explain that? Why would that be? Joseph, why would that be? Well, let's see. So let's go organized here. So if this one is parallel to that one, and this second one is parallel to the third one, that means 1 is parallel to 3, right? That's the transitive theorem of parallel lines. If 1 is parallel to 3 and 3 is parallel to 4, I can use the same theorem to get me down here. And I can just keep doing that, right? And eventually I'm going to get to the bottom. So I'm using that, that transitivity. So rung 1 is parallel to rung 2, and rung 2 is parallel to rung 3. Therefore, right, remember the 3 dots, that means therefore, rung 1 is parallel to rung 3 by the transitive theorem of parallel lines. And you just kind of repeat that process. So it's just something you can do if you have parallel lines. So again, not too tough, right? It's nice when they're sort of semi-obvious. Okay. I want to go back to review. This is going back to those deep dark days of Algebra 1. Remember those deep dark days? What do you mean grown? No, yeah. Those are happy days. So we're going to review how you algebraically prove lines are parallel or perpendicular. Blast from the past. Look at that thing. Slope. Remember delta y over delta x?
I've been traumatized by that song.
Is there a song? Okay, yeah. Well, I didn't use the song for this. So y2 minus y went over x2 minus x1. Changing y over changing x. That's how you describe slope. And look at that Mr. Potato Head. And he was saying that parallel lines have the same slope, right? So these ones have a 0 slope, because Mr. Potato Head can walk on them. So horizontal lines, right? And think of the tilt. The tilt is exactly the same for both. Slope is basically, quantifying the tilt of a line. So if their tilt is the same, they're parallel. The perpendicular lines were maybe a little bit less obvious to see. So if you've got one line here and another line here, the slopes are negative reciprocal. Now, why is this actually a bad example of that? Yeah. What's the slope of this guy? What's the slope of that thing? Infinite? No. What's the slope? You said it already, haven't you? Undefined. I can't define this slope. This is as slopey as I can get it. And I need the biggest number possible to define its slope, and we don't have the biggest number possible.
Infinity.
Well, infinite is not a number, right? So it's just we cannot get there. So undefined number. Yeah.
Well, if you could like speak out about vertical,
walk on it, that's something that doesn't have like a slope that's gonna make you fall down. So that's like the zero slope. And then as you lift it, the slope gets bigger and bigger and bigger until I'm straight up and down, and then I need the biggest number there is to describe it, and I don't have a biggest number there is. Yeah, so my vertical lines have an undefined slope. So again, review.
Excuse me? Excuse me?
Okay, let's look at this one now. Just as review, a positive slope as x increases. So if you have a positive slope, as the x's get bigger, what happens to the y's? Do they increase or decrease or stay the same? What happens, Amanda?
It increases.
They increase as well. And which of these lines here shows a line with a positive slope?
Wait a
Dave,
second,
J,
this
K,
is
or
on my
L?
sheet.
No, so just look up there. Just look up on the board.
Is everyone else doing that? I think everyone else is.
Which of the lines here, raise your hand if you know, is showing a positive slope? Abby, which one is that? Okay, right? So as x gets bigger, so does y, and that's line K. A negative slope, so as the x's get bigger, what happens to the y's? Now, which line is illustrating that one? Amy? And what happens to the y's as x gets bigger? It decreases. So here we see the x is getting bigger, our y's are getting smaller. That is a negative slope. Which one of these is a zero slope? Is it the vertical or the horizontal? And which one is it? There better be more than one person who knows this, because that would be a problem if that's true. Kyle, what is it? Line X. Oh, that's my XY axis. So I'm looking for one of the blue ones. Line L, right? It's a horizontal line. And X, you're right, the x-axis does have a zero slope as well. And I need a line with an undefined slope. Which one is that one going to be? Amanda, which one is that?
The line will be vertical. And an example of that is line N.
Good. That's exactly right. Sorry? I don't know. Oh, I think because when I took this picture, they didn't label that line, so I did it myself. Alrighty. Okay, some new postulates, but not new information. We know this already from Algebra 1. So this is now a postulate, so it's a fact. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. And why did I say two non-vertical lines are parallel? And then I kind of have another kind of secondary statement here. If they are vertical, any two vertical lines are parallel. So why did I have to kind of separate that out? Why is that, Jeff?
Because both a divided by 0 and 0 divided by 0 is undefined. However, 0 divided by 0 can be literally any number.
What are we
and
talking about?
You can't have a number big enough for
I don't know why. Why are we doing 0 minus 0? You back me up.
It's 0
Okay,
divided
let
by
me
0.
answer that because you're right. There's some right information there, but when you dive right in, it's like you're skipping steps. So why are you going to 0 minus 0?
Because that
0 divided by
0
0.
divided by 0.
Well, why are we going there?
Because that's an undefined.
But what about 5 over 0?
That's also an undefined.
Right, so why do I have to be 0 over 0? I don't, right? What is the
I'm just
important
saying
part
there
there?
are multiple types of undefined, because 0 divided by 0 is any number.
How does this answer the question, why do I have to say non-vertical lines here and separate out my statement about vertical lines?
Because there are multiple types of undefined.
Okay, I don't think that answers that question. That is true what you're stating, but I'm not sure how that answers the question. Why I need two separate statements here. Non-vertical lines have the same slope, and just assume if you see any vertical lines that they are parallel. So why do I do that? I just want everybody to have a little bit of big time here. What do you think, Evan? That's true, and what is that? Well, it's undefined. Vertical lines don't have a slope. Right? So I can't say any lines that have the same slope, this will work, because some lines don't have a slope. So those lines are the vertical lines. So non-vertical lines will all have a slope. I can use this statement. If you find vertical lines, they're parallel. Okay, so that's why we're doing that. Perpendicular lines, two non-vertical lines, again non-vertical, are perpendicular if and only if, and this is also an if and only if, these are bidirectional, the product of their slopes is -1. And then we're pulling out the vertical line case because it doesn't have a slope. So if you have a vertical line and a horizontal line, they are considered perpendicular. So you don't compare slopes, you just say because they are horizontal and vertical, they are. We learned this maybe using different language last year. Last year we said lines are perpendicular if they're negative reciprocals of each other. So let's review what a negative reciprocal is. So if one line has a slope of 2/3, what's its negative reciprocal? Amy? Negative 3/2. So remember what you do. It says take the other side and then, turn them upside down. Well, what's the product of negative reciprocals? I can reduce, and I'm going to get -1. So it's a different way of saying the same thing. Okay. Let's see what else we have here. So now we just want to know, are these lines parallel or not? Let's take a look. I'm using a little notation here. This is like a subscript. So I'm asking you for the slope of K1, the slope of K2, slope of K3. We're middle page 2 here. So first of all, to find out if they're parallel, you find their slope and compare, right? So if they're parallel, what should I be looking for? What am I comparing? Where'd you go? No, I'm just looking at everybody's like, God, what am I doing here? Why am I finding the slope? What am I going to do with that? That's a good question.
I mean,
Oh, no, I'm looking for everybody else. I know you know, and I know a couple of people know. Everybody should know this. I'm worried about what happened in Algebra 1, and we can't answer this question.
we had bad teachers in Algebra 1.
Why are we doing this? Yes? To determine if they're parallel, but why am I finding the slope? What did the postulate or the theorem, what did it just say? Yeah, and so what does that say? Same slope. So I'm looking for slopes that are equal, right? That's what I'm looking for here. So what is the slope of K1? Remember, slope is change in y over change in x. So I'm going to just count my boxes. I'm going to use that method. 1, 2, 3, 4. That's my change in y over 1. So that one has a slope of 4. Now let's look at the slope of 2 here. 1, 2, 3, 4. That's my numerator over 1. So that one is also going to be 4. And let's look at the slope of 3. So I look for, again, 2 points here. 1, 2, 3, 4, 5 over 1. So this one has the slope of 5. So what's my conclusion? Do I have any parallel lines? And if so, which ones? Joseph? Lines K1 and K2 will be parallel because they have the same slope. And this is a little bit neater than what I wrote. And you can see what it says. Okay, so we did this last year. I'm concerned that only 2 people seem to remember, even if all the teachers last year were terrible. All right, graph the parallel line to AB that passes through point B. So now I want a line parallel to AB that goes through point B. Well, first bit of information I need to know is what is the slope of AB? Well, let me see. Even though they're showing me these two, I actually see some points here I can use. So what's the slope going to be, Amy? Do you see it? 1, because I'm up 1, right 1. So I've got a slope of 1. And then, so what is the slope of my parallel line going to be? Also going to be 1, right? And if you have a point and you have a slope, I can certainly graph that. So if here's a point to start with, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Or I can go down 1, left 1, down 1, left 1, down 1, left 1. And so now I am going to make my line parallel, right? Same slope. Did this last year, right? Raise your hand if you did this last year. Okay, good. All right, let's look at this other example. I'm going to graph the line perpendicular to AB that goes through point P. Okay, well, I still need a slope of AB. It still looks like it's 1, right? Up 1, right 1, up 1, right 1, up 1, right 1. It still has a slope of what? Now be careful now, I have to find the perpendicular. How do I find the slope of the perpendicular line, Joseph? Negative reciprocal. What's the negative reciprocal of 1? Negative 1, right? Because it's 1 over 1. You take the opposite side. When you turn them, it's the same number. So now I'm going to start at P. Negative 1 over 1, that's a down 1, right 1, isn't it? So I go down 1, right 1, down 1, right 1, down 1, right 1. I could do the opposite and go up 1, left 1 as well. There it is. So this line, I know is perpendicular to the other one, because if you multiply their slopes together, you will get -1. Other way of thinking about that is they're negative reciprocals. So a couple of tries here. All I want you to do is give them these two lines, 2 points on the two lines, and decide if they're parallel, perpendicular, or if they're not. We can't see. Let me see. I can show you what I
Well,
got.
I think it's just really just more simple.
So I got perpendicular, neither, and parallel. Do we match or not match? Or question on how we even map here? 5 minus 2 is 3. -3 minus -5, that's 2, right? 0 minus 2 is -2. 1 minus -2 is 3. Negative reciprocals, or multiply them together, you're going to get -1 that's perpendicular. Okay, so questions. Because that's it, right? That's it on the first part of this. Now, I gave you notes for the second part. Actually, this is more review from Algebra 1. And writing equations of lines. So we did this last year. So let's see how we do this. Let's review. Writing a linear equation from a graph. So what is the slope-intercept form of a linear equation? Slope-intercept form, Joseph. Y equals mx plus b, where y and x, we know what that is. What is m? Slope, and what's b? The y-intercept, right? So we put it in that form. So let's see, I've got my equation here. So we're going to write an equation of a line from a graph. Now, first thing we have to get is the slope, because I need my slope. So we reviewed this a little bit just a few moments ago. Let's start from here. So I've got 2 points here. I can even find 2 points a little closer. That might make this easier. So I'm basically going up to left one, up to left one, up to left one. So that means up is positive, left one, that's negative, right? If you're going up, you're positive. If you're going left, you're negative, right? If you're going right, you got -2. So -2. Now the point slope formula states, do you remember what it is? Yeah, what is it?
Y minus y1 is equal to m times x minus x.
Awesome. Who else remembered the point slope formula? That is awesome. That is fantastic. This is a really helpful little formula, because what it says is, if you know the slope, and the x1, y1, that's a point on the graph. So if you know a point and you know a slope, you use point slope. So I can pick any point I want. For this example, I'm going to pick 3, -2. I could pick any point I want. And here's how you use point slope formula to get the slope-intercept form of the equation. So this is my x1 and this is my y1. So I'm going to use this formula. Y minus y1. Minus -2 is a +2 equals my slope, -2 times x minus x1, 3. So now I do my distribution. Y plus 2 equals -2x plus 6. I'm going to subtract 2 from both sides. Y equals -2x plus 4. I do check this. Y equals mx plus b. So there's my -2. I actually maybe plug my point back in. So -2 times 3 is -6. -6 plus 4 is -2. That point actually works. Looking at my graph, it looks pretty much like it works as well. Because there's my y-intercept and my slope of -2. I get to that here. There is a second way to do this. And that's, I think, what Amanda did, was she said, okay, I know what the slope is, it's -2. But look, here's my b staring me in the face. So if I know m is -2, and I know my b is 4, all I have to do is just put that into y equals mx plus b.
No, that's
So,
not what I did.
That's not what you did? I just wanted to kind of point out, if you know b, it's much, much simpler. Just find the slope, use b, and put it together, if you know b. If you don't know b, or if you want to, you can use point slope formula. Do you remember doing this last year? Everybody raise your hand. I remember doing this last year. Okay, it's back. Alrighty. So graphing linear equations, I want to review that as well, just to make sure we're all on the same page with that. So if I want to graph the equation 3x plus 4y equals 12, slope-intercept form, whoa, where's that coming from? Let's see. So I want to solve for y. So I'm going to subtract 3x from both sides. Solve for y, so I get 4y equals -3x plus 12. and then I'm going to divide everything, right? Everything gets divided by that 4, so I can isolate the y, and I get y equals negative 3/4 x plus 12 over 4 is 3, and that looks like that's where that came from. So to graph it, oh, that's easier. To graph it, my m is negative 3/4, and my slope is 3. Do you have a question or a comment? Yeah, what's your question? Huh? I don't know. What's the question? What opposite way? Now I understand what you're saying. So I'm going to go to my y-intercept of 3, and then I'm going to go down 3, right 4. 1, 2, 3, 1, 2, 3, 4. Alternatively, you can go the opposite direction, up 3 and left 4. 1, 2, 3. I'm kind of off my own chart here, but I could have. And then I want to have at least 2 points, because now we know officially that 2 points determine a line. I can graph my line. I want to review another method, which is the intercept method, the x-intercept and y-intercept method. How do you find them? Often when they're presented in this standard form, remember ax plus by equals c, we can use the intercept method. To find the next intercept, x-intercepts live here, your y value is 0. So this kind of like becomes 0. So you get 3x equals 12. So x equals 4. I know my y-intercept, my y value there is going to be a 0 for an x-intercept. To find the y-intercept, that's this way. Your x value is 0, so you set the x equal to 0. And so I'm left with 4y equals 12. So y equals 3, 0, 3. And I can find 2 points this way. 1, 2, 3, 4, and 0, 1, 2, 3. Just another method. Sometimes it's easier depending on what your equation looks like. So you have choices. All right? Who remembers this? Raise your... No one! Oh my goodness. Okay.
I know.
Okay, you remember. That's good. But not everybody. That's
Wait,
worrisome.
actually, no.
Get back. Okay, so now we're writing equations of parallel lines. Again, we did this last year. We're going to write an equation of a line that passes through point -1 and it's parallel to the line with this equation. So what am I actually doing here? Let me just make a little sketch here. I've got a line at y equals 2x minus 3. So I'm going to sketch that. So I'm at -3 up to the right one, right? So I have some line that kind of looks a little bit like this. I'm sketching it. And then at -1, 1, I want the equation of this line that I'm doing right here, this little dotted line. I want it to go through the point -1, 1, and I want it to be parallel to my given line. Okay, so that's what I'm trying to find, the equation of this line right here. So parallel lines have slopes that are, what goes in that line? Yeah? Equal, right? Equal or same. So, let's see what I got here. Parallel lines have slopes that are equal. And so the slope of the given equation. So here's my given equation. What's its slope? Abby? 2. So the new line that I'm drawing, since it's parallel, what's its slope going to be? What's the slope of my dotted line here? Yeah. 2, because parallel lines have slopes that are equal. And my new line, I know the point that's on it, -1, 1. So I have a point, and I have a slope, so I'm going to use point slope. Oops, that's 1. So y minus y1, that's 1, equals my slope of 2 times x minus -1. A minus minus is a plus. So y minus 1 equals 2x plus 2. Add 1 to both sides. Y equals 2x plus 3. Right? And I can test it a little bit. First of all, it does have the same slope. If I plug in the point -1 and 1, is that a solution? Well, if you plug in an x of -1, 2 times -1 is -2. -2 plus 3 is 1, which is what I wanted to get. So I plug in that point just to make sure it still works. So there is the equation of that line. We did this last year. Remember? Remember? No one.
Wait, what?
Thank you. We did this last year, right? Yes. Okay. And we also did it with perpendicular lines. So just to do another example, perpendicular lines have slopes that are, negative reciprocals. Or you can say their slopes have a product of -1.
This person trying to get
Alrighty, so let's see. I've got my given equation here. So again, if I'm drawing a sketch of this, y equals negative 2x plus 2. So there I am at 2, down to the right one. So I have a line that kind of looks like this. And then at point 2,3, wherever that is, I'm kind of guessing, I want to make this line now. So I'm looking for the equation of that line that's perpendicular. So the slope of this one is negative 2. So what's the slope of this dotted line going to be here, my new line that I'm creating? What's that going to be? What? 1/2. Negative reciprocal. So you take the opposite sign. That's really 2 over 1. Turn it upside down. And then the point that they want it to go through is point 2,3. So now I'm going to do y minus y1 equals m times x. Whoops. Wow, that was loud. X minus x1. So there is my, whoops, my x1 and my y1. Y minus 3 equals 1/2 x minus 2. We're going to distribute that half. Y minus 3 equals half x minus half of 2 is 1. I'm going to add 3 to both sides. Y equals half x plus 2. And I always make mistakes here. I just want to check it. If I plug a 2 in, I should get a 3 as my y. Half of 2 is 1. 1 plus 2 is 3. Okay? Alrighty. That's our algebra review. Which means we should be able to kind of do these. It's just practice. Do these, just spend a couple minutes. I'm not sure we'll even get through all of them, but give it a try just for practice. I'll put the answers up so as you're working, if you want to check how you're doing, you can. If you're finding that you're making some mistakes or you're not sure where this is coming from, or if I made a mistake, which is extremely possible, just let me know. We can talk about it. If you're doing this one with the intercept method, you would say to find an x-intercept. Right, that's along this line. That means the y value is 0. So you plug in a 0 here. 3 times 0 is 0. You're left with 2x equals 18. So x would be 9. So my x-intercept would be 9, 0. If you want the y-intercept, y-intercepts are along right on the y-axis. So your x value is 0. 2 times 0 is 0. So you're left with 3y equals 18. So your y would be 6. Your x is 0. Your y is 6. And I'm counting by 2's on here. Because there's just not enough room. So 2, 4, 6, 8, and kind of in between there is 9, 0, and 2, 4, 6 over here. So yeah, you can use the, sometimes the intercept method is easier, depending on what you have as your equation. Or you can solve this for y and use point slope. How far did we get? Are we all get number 1? Anybody not get number 1? Number 2, anybody not get this? I just do it. How about these two? Please ask if you have a question. You guys look quiet, but I want to make sure we get this. Cal, can you just kind of measure so close in here? Okay. All right, let's move on. It sounds like we're okay. Now we're kind of back in geometry land, or at least what we're doing this year. Some perpendicular line theorems. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Now I've got a bunch of proofs behind here. Let's see if we can talk through these rather than go through these formal proofs. So let's see, two lines intersect to form a linear pair, correct? If they are a linear pair, then they are supplementary by the linear pair postulate. If the lines are congruent, that means they have the same measure. So if this one has a measure of x, and this one will have a measure of x, right? That's what congruent means. They have the same measure. Since they are supplementary, by definition, they're going to add up to 180 degrees. And then I'm going to use some math. And the division property of equality is going to tell us that each x must be 90 degrees. And if each x is 90 degrees, that means they're right angles by definition of the right angle. And if two lines form to make the right angle, then they are perpendicular. Definition of perpendicular. Okay, so now we believe it. If two lines are perpendicular, then they intersect to form four right angles. And I think in here we actually did talk about why that works. So I know they have at least one right angle by definition of perpendicular. And I can use kind of this same idea here. I've got a linear pair. Because by definition that's a linear pair. Linear pair postulate says they're going to be supplementary. And then the same reasoning I used above, that'll mean this one's 90. Here's another linear pair. That's going to mean that one's 90. And so by using that same logic all the way around, we can see that one right angle implies four right angles. if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So I've got my adjacent angles here. So meaning these outside rays here, these two sides, are perpendicular. Well, by the angle addition postulate, I see that 1 and 2 add up to that third thing. That means 1 and 2 add up to 90 degrees. That's the definition of complementary. Perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it must be perpendicular to the other parallel lines. Well, let's see. Okay, if this is 90, what do I know about, say, this angle? What's that going to be? Y. Oh, what is that one? That's one of our new ones. That's what are the words we need to say? Do you remember what we need to say here? Corresponding angle something. Corresponding angles of parallel lines are congruent. It's the corresponding angle postulate. I would never remember the name. Corresponding angles of parallel lines are congruent. So because this is now a right angle, I can see that it's perpendicular. And the other one, we have lines perpendicular to a transversal, kind of like this one. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So we're going to be using more of those Converse theorems we looked at. So let's see, two lines are perpendicular, so N and N are both perpendicular to P. So by definition, I have right angles here. Now if I kind of look sideways, this is kind of like two lines with a transversal, and their corresponding angles are congruent. So this is a converse of the corresponding angle postulate. So if two, I got to turn this out a little bit. So if two corresponding angles are congruent, then the lines are parallel. So I'm working backwards. So there, I proved it. And so now, guess what we don't have to do? I don't have to do all of these. Now again, if you want to see the detail of this, this is posted online, so you can look online here. But that's really now, we're just applying these different new theorems postulates to solve these problems. Okay, so use those new theorems and see if we can solve these. I'm not trying to rush anybody. Some people are done, some people are still working, that's all fine. If you are done, if you want to see if we agree on our answers here. And let's see if we have any questions on that. If ABC and ABD are congruent, I can see that they're a linear pair, so by our new little theorem, the two lines intersect to form a linear pair of congruent angles, and the lines are perpendicular, so that means if they're perpendicular, then these are both 90-degree angles. These two angles are adding up to 90, so they must be complementary. To find this value of x, because one of those angles is a right angle, it means all of those angles are right angles. So if this is a right angle, 2x plus x is 90, so x is 30. And then determine which of any of these must be parallel. So because I see this, I see that two consecutive interior angles are supplementary. They are adding up to 180. I'm using that fact, not the fact that they're congruent, to determine that this one and this one must be congruent. So that gives me P and Q. And then now I'm kind of turning my head sideways a little bit. I'm looking at S and T now, and I'm seeing that my corresponding angles are congruent. Therefore, these lines must also be parallel. But why can I not make any conclusions about line U? How come not this one? Yeah, Julia? There's no way?
There's no proof. They can't prove it because we only know that like the angle of like the x or like the x and q or something are like are right inverse angles to the perpendicular, and then the same like the x and the p and the
Good. Yeah, I mean, if you think about this picture, like let's say it was redrawn, again, my picture the hard over, PQ, STU, and then, so I've got this and I've got this. Well, look, instead of making it straight up and down, instead of making PQ straight up and down, what's to prevent me from thinking that it's going like this? I mean, I don't know if it is or not, because they're not telling me these are right angles. It could be slanty. I just can't tell. So we don't go by what it looks like. So any questions on that? Okay, this little topic, it's kind of like a bonus topic, distance from a point on a line, and it's a good review of distance. So we'll do this a little, fairly quickly here. Distance from a point to a line is the length of the perpendicular segment. So if you have a point to a line, if you have even a line to a line, like how do you measure the distance? You have to drop a perpendicular to it. So you would drop a perpendicular. That would be how you tell distance. You don't draw a line like this and say that's the distance. You want that perpendicular line to be your distance measure. So the distance between two parallel lines is the length of any perpendicular segment joining the two lines. So parallel lines, you have to have a perpendicular segment, and that would be the length between them, the distance between them. So any other segment is not distance between two parallel lines. So let's remind ourselves of the distance formula. Who remembers it? Goodness gracious. Jack, what is it?
Square root of x minus x1 squared plus y minus y1 squared.
Okay. I'm calling it x2 minus x1. You just said x and x2, which is fine. Understood that they're different x's, right? And different y's. So if you have 2 points, x1, y1, and x2, y2, it's these different, very complicated looking ones. I remember it as the square root of a squared plus b squared, because that's easier for me to remember because it's like the Pythagorean theorem solved for c, and that a is really the distance between the x's, and b is really the distance between the y's. So that helps me remember this somewhat confusing looking formula. So, okay, great. Now if I were to find the distance between these two lines, and I'm on the back now, page 3, okay. Yeah, okay. So I look at this one, I say, gee, I need a perpendicular line to drop through here. Well, let's see. What are the slopes of these lines? Looks like I've got a point here, and it looks like it's going here. 1, 2, 3, 4, and then a 1. So it looks like the slope of that line is 4. Let me just see. Let me make sure they're parallel. So let me just check. Yeah, they look like 1, 2, 1, 2, 3, 4, 1. So that one also has a slope of 4. So they are parallel lines. So I basically have to find a perpendicular line between them. Now what would the slope of the perpendicular line be? Yeah? Great, right? -1/4, you took the negative reciprocal. So whatever line I'm drawing is going to have a slope of -1. So you're going to start at a point somewhere. I'm going to start here. Maybe you want to start here. It doesn't matter so much. But I like finding a nice point that is an integer value, x and y. And then I go down 1, and then I'm going to go right 4. 1, 2, 3, 4. And I'm hitting right here. Now I know this is perpendicular because these have a slope of 4, and these have a slope of -1/4. So they are perpendicular lines. If I want to find the distance between these two lines, I look at this value, which is 0, 0. And then this one, which is 1, 2, 3, 4, -1. So I've got those 2 points here. And if you use different points, you might have different ones. So there they are. And then I'm going to use the distance formula. Hopefully I did this right. The distance formula. So the distance between the x's is 4 units. And then I'm going to square it. And the distance between the y's is 1 unit. It says -1, but they are 1 apart. And I'm going to square that. And I'm getting the square root of 16 plus 1, which is the square root of 17. Which, if I want the exact answer, I'll just leave it as square root of 17. If they wanted an estimate, I think on your paper it says round to the nearest 10. So if I want to do that, I just get out my calculator. And I say square root of 17 to the nearest 10th is about 4.1. So that would be the distance or the length between these two lines. That's all. That's it. Here's another one. Distance between a point and a line, or two lines. So what's the distance between the graph of y equals x plus 1 and this point? Well, first of all, let's graph this line. I'm going to use point slope. So my m is 1, and so is my y-intercept. They're both 1s. So I start at 1, up 1, right 1, up 1, right 1. Just graphing y equals x plus 1. So you can go ahead and graph that as well. And I'm on the back here if you don't know where we are. And I wanted the distance between that and 1, 2, 3, 4, 1.41. So I want to find this distance here. So what's the slope of this line? Slope of the line that we started with? Yeah, 1. So what is the slope of the line that I'm going to use to measure the distance? Right? I have to drop a perpendicular. So what would the slope of that line be? This line is 1. What would the slope of the perpendicular be? Joseph? Negative 1, right? So it's the negative reciprocal. Either we're just being quiet or we don't get it, so I'm concerned which one it is. So I want a slope of negative 1 here. So let me go back. I think I might do this slightly different way. I go up 1, left 1, up 1, left 1. I can actually see my point of intersection, so I think that might be the easiest way to handle this. I don't necessarily need the equation. I'm gonna change this just so you can do this if you want. This comes in handy if they don't meet up in a nice little point here, but this one is, so I'm just going to do it that way. Where are they meeting? What are the coordinates of that point right here? 2, 1, 2, 3. It meets at 2, 3. So to find the distance from this point to that line, I'm going to find the distance between 4, 1 and 2, 3. So again, my distance formula, you take the square root of the distance between the x's. What's the distance between 4 and 2? Anybody? Distance between 4 and 2? Yeah, 2. And I'm going to square it. Then I'm going to add the distance between the y's. So I'm looking at 1 and 3. What's the distance between that? Also 2. I'm going to square it. So it's the square root of 4 plus 4, which is the square root of 8. If I want an exact answer, I want to just reduce that radically, right? 8 is 4 times 2, so this becomes 2 rad 2. If I wanted to the nearest 10, I can just put it in my calculator. The square root of 8 is approximately 2.8 to the nearest 10. How am I doing on the distance? So these can be a little bit tricky. So if you want to try those, you try to give them a shot. Don't get too frustrated trying to think of that first one. First one works. It should be okay. Give it a try and see how that goes.